Welcome. This is a quick video introducing the CEA-2045 open standard for smart grid communications. CEA-2045 was designed to allow communication modules like these to provide communications between machines that use electricity, gas, and water, and the smart grid that needs to better manage these precious resources. The standard was developed by the Electric Power Research Institute and the Consumer Electronics Association and is being promoted by the USNAP Alliance. The standard has these two formats for communicating modules, DC powered and AC powered. Today we will be showing you modules that use Wi-Fi, but many other communication paths are possible. The advantage of the standard is that module manufacturers like SkyCentrics can quickly team up with major manufacturers and connect their well-known brands of machines and appliances to the smart grid. Here you see a DC module inside an Emerson water heater switch. This can be retrofitted onto already installed 30-amp electric water heaters. Here the DC module is placed inside an Emerson thermostat. The larger AC power module can be placed inside an Island Air PTAC unit. This is a heating and cooling system that is placed inside the wall sleeve found in hotels and apartment buildings. In this detail you can see the module next to the connector on the PTAC. And currently the AC module can also be put on an A.O. Smith water heater. Once the CEA module is placed onto an appliance and connected to the internet, then a building owner can go to the SkyCentrics portal and add a device to his account. He does this by giving the device a name, such as My PTAC, and choosing the AC module. When he does that, he's presented with the devices he can connect it to, the Island Air PTAC unit, A.O. Smith water heaters, and the Vaughan water heater. If he had chosen the DC, he could choose between the Emerson water heater switch, pool pump switch, and thermostat. Here we have already added the devices to our account. The Emerson water heater switch is live, as you can see on this webcam. You can also see some more traditional SkyCentrics connected devices, such as this rooftop unit monitor, with a current transformer connected to it that is reading the power from this heater, and temperature sensors connected to it, monitoring the heater and the ice water here as examples of supply and return air to the rooftop unit. The watt stopper here is reading the power of the heater, and the SkySnap RTU back here is also reading that power. And the temperature sensors are here showing cold, hot, and room temperature. In a similar fashion, the Emerson switch is showing its status. Here it's showing the building owner has chosen it to be on, and it's showing that it is currently energized and thus in normal running mode and drawing 4.5 kilowatts. This shows that it's actually heating the water right now. After all, the utility needs to know when the heater is on or off so that it knows if it's available to shed its load at critical times, such as the peaks of usage during the hottest days of summer. On our camera, this heater is plugged into the Emerson switch through this plug. That means that I can remotely turn the plug off here, where it says heater plug, and that will emulate the water heater stopping to heat the water. As you can see, the Emerson switch now shows that it's not energized, it's in idle normal state, and it's drawing 0 kilowatt hours. For the rest of the demonstration, however, I'm going to want that heater to be on. If the building is going to be empty for a week, such as when the owner is on vacation, the owner can turn off his hot water heater directly through the CEA standard by right here. This actually turns the Emerson switch off. And because he can do this through the internet with his phone, he can turn that water heater back on before he comes home. Or he can schedule it like he would with a thermostat in a scheduler on our portal. Currently, the Island Air PTAC unit and the A.O. Smith water heater are virtual devices running on an EPRI emulator running on a computer. That is why some of the data fields are missing. But through the CEA Open Standard, we can still read information from the device. For example, the utility can know exactly the instantaneous power being consumed and the total energy consumed for this device. And it knows that the measurements are in watts and watt hours. The CEA standard also allows the building owner to see information on his device, such as the firmware and the build version, which might be handy for a tech support call to the manufacturer. The standard can also tell the building owner the price of electricity and the fact that no grid event is currently called for, and if there was a grid event, when that grid event would be ending. Let's see how a utility might use the standard to help manage the smart grid on a hot summer day. It would go to a demand response event creator such as our DR admin page. It would give the event a name. It would choose a start time. It would choose a duration, 5 minutes, and then it would choose the event type. This CPE is a critical peak event. However, it could also choose GE, grid emergency, GG, grid guidance, bad, neutral, or good, or power level, where it can communicate a power level to complex machines where those machines, instead of just turning on and off, can actually reduce their load, for example, by 63%. Here, email or text communications can be sent to the building owners notifying them of the creation of the event or the start of the event, and they are given the ability to opt out if they choose to do so, although they are obviously given incentives by the utility to forego opting out. Then they start the event. As you can see, the event has been created, and now shortly these devices are going to start responding to the event. We can hit refresh to see it happen more quickly with one of the devices. Here, the Emerson switch has received the communication from the smart grid. You can see the color change indicating this to the building owner, and the event has end time so that he knows when the event will end. Also, now the Emerson switch has responded by being non-energized in idle grid mode and drawing 0 kilowatts. In summary, the CEA-2045 standard provides 2 valuable communication paths. The first is to the utility for the critical grid management functions that we all need to better manage our precious energy resources. The second is a byproduct of the fact that the CEA standard connects devices to the internet. This means that the owners of the device also get a huge benefit. They can monitor and control their device remotely through the internet, or their Android phone, or their iPhone to better schedule and manage their large energy appliances, giving them more comfort, convenience, and savings. Thank you for listening.